Hey guys, we're going to continue with our discussion on weathering. Rocks break down both physically and chemically. The rate at which these rocks break down are influenced by several factors. One factor that's required in order for rocks to break down is, of course, exposure. The more the rock is exposed to the atmosphere and to the elements like rain and wind, the more likely it's going to break down and the faster it'll break down. Rocks do not break down when they're buried within the crust. Only after they're exposed do they start to break down. And the more exposed they are, the faster they break down. As rocks break down, their surface area actually increases. If we have one solid rock and then we start to fragment the rock into smaller and smaller and smaller pieces, the surface area actually increases. That's because as you break the rock down, the more surfaces are exposed to the surrounding environment. For example, when we have a cube of sugar and granulated sugar, powdered sugar, the powdered sugar will dissolve more quickly when we put it in the coffee than the cube of sugar. That has to do with the amount of surface area and the exposure of those surfaces to the hot water, which will chemically dissolve the sugar. The type of material also influences the rate of weathering. Hard minerals on the Mohs hardness scale weather more slowly compared to soft minerals. So harder minerals are more resistant to weathering. They break down more slowly, whereas soft minerals break down more quickly. Here we have what we call a sea stack. The surrounding rock was obliterated by wave action. It was weathered, but a portion of the rock stood the test of time because the mineral composition was composed of minerals that were very hard and resistant to weathering, and therefore the sea stack stood and resisted the weathering. We can see this in an outcrop. Here we have exposed rocks to the atmosphere, layer 1, layer 2, layer 3 we can see juts out the most, and layer 4 is pretty weathered. The rock layer that is most resistant to weathering would be rock layer 3, because as you can see, it's been weathered the least when compared to 1, 2, and 4. This happens along waterfalls sometimes. All of that roiling water at the base or the cliff of the waterfall actually weathers through abrasion the rocks at the bottom of the waterfall. You can see different layers. And depending on the composition and the hardness of those minerals, each layer weathers at different rates. Climate also influences the rate of weathering. Climate's determined by temperature. Is it hot? Is it cold? And moisture. Is it moist or is it dry? Is it wet or dry? Physical weathering tends to dominate in climates that are cold and moist. That's because you need those cold temperatures to freeze the water, which then expands to break down the rock through frost action. Expansion and contraction of rock is a physical process, and you need those cold temperatures along with moisture to break down the rock. Hot temperatures, on the other hand, drive chemical reactions. They're considered a catalyst. Think of the experiment we did with the Alka-Seltzer tablet. Hot water dissolved the Alka-Seltzer tablet faster because it moves the molecules more quickly. And the faster those molecules occur, and the faster they move, the more likely there will be collisions to create chemical reactions. So hot and moist conditions are required for chemical weathering. The key commonality is moisture. You need moisture. It's the natural lubricant. It helps in physical weathering, and it's required to dissolve material in chemical weathering. Here are 2 Cleopatra needles. These needles were created back when Egypt was a dominant civilization. Etched into them are ancient writings called hieroglyphics. One of these was left in Egypt in a dry climate. You can still read it very easily. The other one was transported to New York City. New York City has a lot of precipitation, and therefore there's going to be a lot of physical and chemical weathering, and you can't read it as well. The additional factors that influence weathering are time. Of course, this whole process of weathering takes time, and the longer it's exposed to the atmosphere, the longer it's exposed to tree roots, biological weathering, or chemical weathering with water and acids and gases, or the longer it's exposed to wind, rain, abrasion, thermal expansion, and frost action, the more the rock will break down. Humans also influence weathering. Humans have thoroughly manipulated landscapes. We excavate for Earth's materials, whether it's fossil fuels or precious metals, and we have large machines to do that. Excavating the Earth has broken down Earth's crust dramatically. That's it for today, guys. We'll see you soon.